Hello everyone, welcome to my channel. In this video, I will derive the equation of motion by calculus method. These equations are important for board examination class 11th. So first relation is velocity time relation and equation is v equal to u plus at. Here v is final velocity, u is initial velocity, a is acceleration, t is time. So the instantaneous acceleration of an object in uniformly accelerated motion is given by, so here formula is a equal to dv upon dt, which is instantaneous acceleration. Then a dt equal to dv, which is equation first. Then integrating equation first, integrating equation first within proper limits, within proper limits, which is when time equal to 0, object at rest, that is v equal to u, which is initial velocity, which is initial velocity, when t equal to t, that is object at final velocity, which is v, final velocity. Then equation first becomes integrating a dt within limits 0 to t equal to integration dv limits u to v, means when your object at rest velocity is u and when velocity is v, time is t. Then here is the two formula for integration that I used in this above equation second. So here is first formula, integration of dt is t plus constant when limits are not given, and second formula is t dt, t power t having power n, then integration is t power n plus 1 upon n plus 1 plus constant. These are two formula of integration that is used in equation second. Then a dt equal to integration of dv, which is u to v and 0 to t. Here acceleration is uniform, which is constant. Then a integration 0 to t dt equal to integration u v dv. Then integration of dt is t, then limits shift towards right side 0 to t equal to dv v integration, sorry, limits goes right hand side u to v. Then a upper limits is t minus lower limit 0 equal to upper limits v minus lower limits u. Then it is a dt equal to v minus u. This implies v equal to u plus a t, which is equation first, that is velocity time relation. That is velocity time relation. Okay. Then second equation is s equal to ut plus half at square. This equation is called position time relation. The instantaneous velocity of an object in uniformly accelerated motion is, here is instantaneous velocity, which is given by v equal to dx upon dt, then cross multiply v dt equal to dx, which is equation first. Then using v equal to u plus 80 in above equation, then v equal to u plus 80 and dt equal to dx, equation second. Again integrating equation second within limits that is when time is 0, position is x equal to x naught, which is initial position. When t equal to t, position is x, which is final position. It is initial position when object at rest, and this is final position when object at a time t. Final. Then integrating u plus 80 dt, limits is 0 to t, equal to integration dx, limit is x naught to x. Then integrating 0 to t u dt plus integrating 0 to t a dt equal to integrating dx x naught to x. Then u is constant, 0 to t dt plus a is constant, then a integrating 0 to t dt equal to integration of dx, limits x naught to x. Then integration of dt is t, limit right hand side 0 to t plus a. Here I use the formula, which is t power n plus 1 dt, which is t n plus 1 upon n plus 1. Then here t power is 1, then it gets 2 upon 2, limits 0 to t equal to dx is x, limits x naught to x. Then putting limits in equations, which is t minus 0 plus half a, limits t square minus 0, then x minus x naught. Then simplify this equation, we get ut plus half at square equal to x minus x naught. Here x minus x naught is s, which is displacement, then write above equation as ut plus half at square equal to s, which is our second equation, s equal to ut plus half at square. Okay, then third one is velocity displacement relation. Equation is v square minus u square equal to 2as. This is velocity displacement relation. So the instantaneous acceleration is given by, again, A equal to dv upon dt. Then in above equation, multiply and divide by dx on right side, then a equal to dv upon dt dx upon dx, then a equal to dx upon dt and dv upon dx, then v dv upon dx because velocity is dx upon dt. So here equation is a equal to v dv upon dx, equation first, and this equation is more important for NEET exams and JEE exams. Then integrating the equation, then first we simplifies this equation. We write it as a dx equal to v dv, which is equation second. Then integrating within limits, is when x is x naught, then velocity is u, when object at x, velocity is v. Then integrating equation, integrating a dx, limits is x naught to x equal to integrating v dv, limits u to v. Then a is constant, limit is x naught to x dx equal to integrating u to v dv, then integrating equation a dx is x, limit is x naught to x, right hand side, then here is v 2 upon 2, limit is u to v, because here I again using the formula integrating of t की power n plus 1 dt. Sorry, here formula is t की power n dt equal to t n plus 1 upon n plus 1. Okay, then putting the limits, a x minus x naught upper minus lower equal to half v square minus u square. Then simplify this equation, we get 2a x minus x naught equal to v square minus u square. Again here x minus x naught is the s, which is displacement, then we get 2as equal to v square minus u square, which is our third equation. Okay, then last equation is displacement in nth second of motion. Equation is s nth equal to u plus a upon 2 n minus 1. This is the equation. So consider that an object starts moving with initial velocity u and uniform acceleration a, Let the displacement of the object in nth second of motion be s nth. S here s nth is equal to Sn minus Sn minus 1, which is equation first, where Sn and Sn minus 1 are the displacement of the object in n and n minus 1 second. So the value of Sn and Sn minus 1 can be obtained by putting t equal to n and t equal to n minus 1 in the equation. Equation is s equal to ut plus half at square. Here t equal to n, then s n equal to u, t is n, then plus half a n square, which is equation second. Then when t equal to n minus 1, s n minus 1 equal to u n minus 1 plus half a n minus 1 whole square, which is equation third. Then put this equation second and third in first, we get, so equation becomes is this. Then solving the equation, s nth equal to un plus half a n square bracket close minus un minus u plus half. Here I use the formula a minus b whole square. Then it is n square plus 1 minus 2n. Then open the brackets, s nth un plus half a n square minus un plus u minus half a n square minus half a and plus a 2n upon 2. Then un is cancelled out and half n square also cancel, and 2 and 2. Then we get s nth equal to u minus half a plus a n. Then s nth equal to u, but taking a is common, then we get a half minus, taking minus a common, then half minus n. Then taking LCM, s nth u minus a 1 minus 2n upon 2. Then observe minus sign, we get u plus a upon 2 and 2n minus 1. This is our last equation, which is also important. So these are the derivations of equation of motion by calculus method. In next video, we derive this equation by graphical method. I hope you will understand these equations. Here I use the formula of 2, which is integration of dn dt, which is t power n plus 1 upon n plus 1, and second one is integration of dt is t. These two formula of integration. Thank you for watching. Like, share and subscribe. Thank you.